We'll now turn to Module 3 of Chapter 9, and it's the second take on put-call parity. We'll look at some more advanced relationships related to this idea. First of all, put-call parity can really be thought of in two ways. The first one is, as we've been developing in Module 2, is put-call parity gives us a relationship between prices. The prices of puts, calls, the stock, dividends, T-bills, all those prices have to be related in a very rigid way by the put-call parity equation. Put-call parity is also, however, an equation that can be used to create synthetic securities. In other words, it tells you, by looking at the terms of the equation and rearranging them algebraically, it tells you that you can synthetically create any one of these securities by taking positions in the other. So let's do one example in detail, and then we'll leave the others for you to think through. So if we wanted to create a synthetic stock, how would we create a stock? Namely, create a portfolio that has exactly the same payoff as the stock at time t. Well, if we take this equation and solve it for s, that would mean that we would bring the put over to this side with a negative. We would bring the dividends over with a positive, and we would bring the T-bill over with a positive. And we would now have solved algebraically for S, the price of the stock, but now we're going to interpret this equation as a portfolio. It says that a stock can be synthesized by a long call. We notice that the call has a positive in front of it, so that's a long position. We're going to short a put, sell a put. Why? Because when we bring the put over, it has a negative in front of it, so we're going to short the put. And then we're going to lend, which is the same as invest in, two T-bills. One T-bill has a maturity of K at time T, and the other T-bill might be a collection of T-bills, each maturing on a dividend date. So it basically says that if we wanted to create a stock, we could do so by going long a call, short a put, and then investing in two T-bills. One T-bill, which in fact will mature for the dividends, and one will mature for the strike. Now, we know by put-call parity that in fact this portfolio has to cost the same as S, so we know that from Module 2. So it'll have the same price. And now if we think about the payoffs, why does this portfolio give us intuitively the same payoffs as if we bought the stock directly? Well, first of all, we're going to get the dividends from that collection of T-bills that we bought equal to the present value of dividends. That T-bill will give us a dividend every time it matures. And if we look at the rest of that portfolio, we have a long call and a short put and a T-bill. Well, no matter what the stock price is, we're going to exercise either the put or the call, and the T-bill will be used to balance that, and we'll end up with the stock. So we'll either exercise the call, which means we'll buy the stock for K, and we'll use the T-bill to cover that, or if the stock price is less than K, what does that mean? We're short. So that means that, in fact, we're going to have a cost, and we'll be buying the stock from the long party. We'll use our T-bill to make that purchase, and again, we'll end up with the stock. So either way, we can think it through that at time T, we have exactly the value, the stock. We'll own the stock physically, and prior to time T, we will have all the dividends in our pocket that came from the T-bill we bought to cover those dividends. And the same, I won't go through each of these, but again, the idea is the approach is the same. If you want to create a synthetic T-bill, a synthetic call, a synthetic put, you can do so with the other securities. Now, the importance of this synthetic creation of securities is that it is this observation that allows investors to arbitrage prices. when put-call parity is not obeyed in the market, you can arbitrage it by, let's say, for example, that we determine calls are too expensive. We will sell the market call and we will cover that risk by going long a synthetic call. So we're short a market call, we're long a synthetic call, so we know the payoffs are going to be the same, and we will profit at time zero by that mismatch of prices. When we have continuous dividends, the approach is the same. The equation changes to reflect the continuous dividends, but the synthetic creation of securities works the same. So, for example, if we wanted to create a synthetic stock, what we're actually going to create is a synthetic value of S0 e to the minus delta t. We're going to buy a call, short a put, and invest in a T-bill that matures at K. The cost of that portfolio will be exactly the same as the cost of e to the minus delta t shares. And what will happen is that if we bought e to the minus delta t shares, we know that that would become 1 share at time t. And that's what this portfolio gives us. At time t, it gives us 1 share of S. Same reason, we have a long call, short put, and a strike. And when we implement at time t, we will always end up with 1 share at that time. So for a cost of e to the minus delta t S, which is the present value, the dividend present value of the cost, we will buy, in a sense, we're synthesizing less than 1 share, but it will become 1 share at time t.